The big challenge for robotics is that this robotic data doesn't really exist in the natural world. So that's one big bottleneck that hopefully our project will help to solve. The only real way for you to know whether you build a decent, let's say robotic AI model is to actually test it in the real world. You can train a better embodied AI model if you utilize data that's collected from different robotic types. So if you truly want very generalized foundational robotic model, you actually want to collect data from all kinds of robotic embodiments as far as you can, right? So it should be humanoid, it should be surgical robot, it should be drones, it should be cyber robots. Our goal is basically to use crypto incentives eventually to crowdsource a big data set to hopefully solve, let's say, sidewalk urban navigation. I thought all crypto are scam until I discovered Helium.
Nice, same.
So big shout out to Helium.
Well, Michael, welcome to the Building in Public podcast. I'm joined today by my co-host Sal, and we're here to talk all things AI, robotics, and Frotobots specifically. So, Michael, I want to kick off with a question to you. Maybe like a very high level kind of what is your vision for this space kind of question. But we've seen a lot of advancements in robotics lately, right? We were just talking off camera about food delivery robots and their prevalence in Brickell in Miami, which is the neighborhood I live in. We've also seen even more advancements in the AI industry and sectors. So I think you called the intersection of those two, so robotics and AI, embodied or physical AI. And I'm curious, at what point, if not already, do these two industries really come into contact and come crashing together? And what do you think the intersection of those two industries will look like in the real world?
Great question, and thanks for having me, by the way. So clearly that there's I think the last 1 to 2 years there's a big change, certainly amongst the investors community. I think when we first started, like, robotics is a very dirty vertical, very, very hard to convince investors. And then suddenly, certainly in the Web2 world, like, hundreds of millions, and that's a seed or a Series A round, right? So, and I think a lot of the excitement in a way is justified because, I would say, especially with the advent of the transformer architecture, which has really shown its flexibility to expand in scope in terms of data modalities. So we started off with LLMs; those are text, and then transformer has continued to scale beyond just text, right, to images and videos. So there's definitely a very strong argument that you can make that if you just treat robotics data just as another tokens, not crypto tokens but transformer tokens, then and therefore it should scale. It's just another data modalities. The big challenge for robotics is that this robotic data doesn't really exist in the natural world. So that's one big bottleneck that hopefully our project will help to solve. But actually, increasingly, I would say the last maybe 6 to 9 months, especially since we started working with a lot of researchers in doing embodied AI research. At least for me, I started to realize actually beyond data collection, it's an even bigger challenge could be real world evaluation. And that's where I think you really have to see a distinction between, like, so-called typical AI and embodied AI. So for typical AI, let's say, when I say typical, meaning things that happen in the digital realm, what you find is that you basically only need 3 ingredients. You need data, you need compute, and then you need talent that basically drive improvement in the algorithms. And that's basically what you need, right? So, for example, let's say OpenAI or DeepSeek, if they were to release a new model, what you find is that typically within, say, half a day to 1 day, on AI Twitter, basically all the researchers reviewing this new model will basically have a very good judgment on how good or how bad is that latest model. So meaning the last step of benchmarking or evaluation, it's never a bottleneck, right? Obviously there's no perfect benchmark, and that's why these things, when they get released, there's like 20 other benchmarks that they will go through, but they get to that result really quickly, right? Because everything is digital. You can just run the result and get that. So it never actually slows down the iteration cycle. Now, with robotics, it's completely different, right? Because the only real way for you to know whether you build a decent, let's say, robotic AI model is to actually test it in the real world. And that's the biggest challenge. So I'll give you a concrete example. So let's say if Tesla were to release the next FSD version, and let's say within one day they gather, let's say 1 million miles. And in that 1 million miles, there's no crashes, no disengagement, right? Basically, no so-called real-world failures. The question is, does Tesla or in fact anyone know whether they've truly built a level 5 autonomy model? Because you actually don't really know, because what if in the next mile, the 1 million and first mile, there's a crash? So in that case, actually what you realize is in embodied AI, like the only verifiable facts are actually when basically things go to shit in the real world, unfortunately. But that's the only so-called positive signal, although it's in a bad way, but that's the only verifiable thing. And in fact, until that thing happened, that failure happened, you can't really know for sure whether you have built a very good model. And that's a challenge. And so if you think from that lens, evaluation, which is, I guess, not even a factor of consideration for digital AI, becomes extremely rate limiting for embodied AI. So the only way to overcome that is just have a big fleet of real world robots supposedly doing what they're supposed to do in the real world. And in fact, to collect those failure cases so that you can continue to improve. It's going to be pretty slow. I think it's maybe like what we see in self-driving. I think it's the same that will happen for robotics. It's going to take years. But then again, it will, in my view, this is probably the last frontier on the path of AGI, because all the digital stuff, all the cognitive stuff will be basically surpass humans in the next 2-3 years, let's say. So the only remaining thing, honestly, in my view, would just be robotics and physical AI. Yeah,
Definitely. And obviously AI is taking over, crypto Twitter and crypto broadly this cycle. But I am starting to see way more discussion about geospatial positioning and, mapping of indoor spaces for robots and also outdoor spaces like you guys are talking about. So I think that's definitely the next iteration of AIs, like embodied AI, that's going to be operating in the physical world.
but just on that, right? So mapping, I think there is an intersection with robotics, but it's not direct, I would say. So, I mean, if you look at how we let's say, move around, navigate in the real world, we don't necessarily need a map, let's say. It's pure vision, right? We don't need GPS, we don't need to have an IMU and with a compass in our brain, right? We don't need any of that. It's all vision based. So there's a big part of robotics where supposedly if you really build a truly level 5 autonomous system, you don't need any of those. It's purely just just observation in real time, and that's it. Of course, like having additional meta information like mapping or that, like especially if it's 3, it will help. But I think those are second order and third order. Those are nice to have. In fact, if you truly want very, very performance stuff, you want the model to still be able to move your humanoid or your robotic dogs somehow without those additional mapping details. Yeah. So anyway, that's just want to point that out.
Yeah, we've talked a little bit about the value of the data that you're generating for training, AI models that can power robots. But what about the value of the real world data you're generating just for kind of more digital AI use cases? Like there's been a lot of talk about LLMs are running out of past data, right? Like they've scraped all the data on the internet, which I don't know if is fully true, but I'm assuming we're going to reach a point pretty soon at where it is true. The GRASS project, which is a deep in AI project, which basically allows people to go through individual computers to like scrape the internet, so they're not blocked by data centers. They have coined a term LCR, live context retrieval, which basically allows LLMs to know what's happening on the internet in real time versus like having a cutoff date be like a year in the past. I've kind of been playing around this term LAR, live activity retrieval, from some of the DPINs that are focused on having cameras in the real world, so like 375 AI or HiveMapper or Nadix. Would you say you guys are kind of in a similar vein of generating live activity from the real world? And then obviously your use case is primarily robotics and AI focused, but like, do you also see digital applications for like purely digital use cases for the data that you're generating that's real world?
No, so I actually think it's the opposite. In fact, I think it's more like well, I guess you can make an argument that if you add in robotics data, and really when we talk about robotics data, actually in my mind there are 3 types of robotic data. So if we have time, we can go through those 3. But that you could argue that adding robotics data as an additional modality, you can have a more well-rounded, maybe grounded in these days they call it world models. So there's some aspect to that, but in general, for example, by the way, I'm a huge fan of what Grass is building. Their live retrieval thing. Actually, there's a big difference. So I'll give you an example. So in that case, right, or rather, new information that appears on the internet, right, those kind of data, the shelf life or within like literally maybe 1-2 minutes after a news information come out online, like the utility drops to half, right? The half life of new information is very, very short. And that's for, I think, most digital information that you see online. But if you think about robotics data, it's actually completely not the same. A crash that you record 10 years ago, that data is equally worthwhile today, because physical world doesn't change. Presumably, if you can record that crash, all the surrounding information around that crash. I'm talking about car crash, but it could be any kind of like failure cases for different types of robots. Let's say a robotic arm that's trying to fold clothes and couldn't do it 10 years ago. That piece of data is still as valuable 10 years later, right? So actually that tells you already something about there's a big difference in the type of data and how you may use that data. But I would say, like, for example, what Gross is doing, or like basically, I think especially video data that, let's say, exists on YouTube, those are actually one of the 3 types of data that will really move the needle for robotic AI, and that's something that BitRobot will hopefully do something with it. Maybe hopefully a number of our subnets will do that. Because obviously for us, Frotobots, we started out actually doing like real world robots, and that's like one of the 3 types of data. But I would say video data are equally useful. So to that extent, I would say anyone who can actually somehow gather huge amount of video data, there is a way to use those data in robotics as well. Although there are trade-offs. For example, in theory, you can learn a model by, let's say, watching a lot of like many hours of videos of, let's say, human cooking, let's say. But that probably only will give you a very basic model. It won't be a very performant model. And the intuition is something like, imagine you and I watch thousands of hours of, let's say, Lionel Messi playing football. Ultimately, can I play like Lionel Messi? We can't. So there's this thing called embodiment gap, right? So there are a number of reasons why that's the case, but basically it just doesn't directly transfer. But it's still going to be very useful, I would say. So to that extent, I think like project like Grass will actually really have an impact for robotics in that regard.
Michael, I know we've known each other for a few years. I know you guys have experimented with a bunch of different modalities or like form factors of robots. Y'all had there was the sidewalk robots was the first form factor. I know y'all have experimented with the robotic hand.
Yeah. This is our latest version.
Thing's beautiful, by the way. It looks really cool.
Yeah, thanks, man. It's like, so it's $150. So literally just a toy. But yeah, hopefully very price friendly for DeepIn.
Absolutely. And more recently, we've seen a bunch of there's like a lot of hype around humanoid robots, around the dog form factor. Just curious to get your view on like where do you think the data collected is most focused, and where do you think that like resources are best well spent when it comes to different form factors of robotics?
Yeah. So wow. Okay. I have a few things to say around that. So I think maybe firstly there's this concept of cross-embodiment, and is actually a very hot, I would say, research topic right now in embodied AI. So what cross-embodiment basically means is that you can train in fact, you can train a better embodied AI model if you utilize data that's collected from different robotic types. So let's say, concretely, you can train a model using data collected from robotic dogs and, let's say, sidewalk robot, and yet create a model to fly a drone. Now, it is weird, right? I mean, this model would have never seen drone footage, and yet somehow some of these researchers were able to fly a drone. Now, it's not a great model to fly a drone, honestly, but the fact that it's able to fly a drone roughly tells you that there's this concept of basically positive transfer learning. And so to me, the intuition I have around that is just, all these different robotic types, they ultimately do stuff in the physical world on Earth where gravity is the same everywhere. And so the law of physics kind of it's the same. And so, but what I'm trying to say is that there is actually a path towards, not gathering like it's not just a size of data set anymore. Is in fact, you can have a much smaller potentially like data that you need to collect if you are very careful about the diversity within this data set. So I think so it's a long-winded way to answer the question. So I think it's actually, you actually want to, if you truly want very generalized foundational robotic model, you actually want to collect data from all kinds of robotic embodiments as far as you can, right? So it should be humanoid, it should be surgical robot, it should be drones, it should be cyber robots. And obviously different robots, they are able to do different robotic tasks. Robotic arms, you can fold clothes, cyber robot, you can do navigation. And these are all different, I would say robotic research fields. But there's, I would say increasing, research evidence now that if you somehow fuse all this together, it generalizes actually better. And so actually that's one of the motivation for us to do BitRobot, which is to kind of take our learnings from cyber robot. That's what we started with for the last 2-3 years. But take those lessons and just apply to many other robotic types and also robotic tasks.
Maybe it's a good opportunity to hear more about BitRobot and what it is, how it works, how you guys came to transition from Frotobots to BitRobot.
Yeah, so when we started Frotobots, I would say the first 2 years, our ambition or our goal is basically to use crypto incentives eventually to crowdsource a big data set to hopefully solve, let's say, sidewalk urban navigation, right? And but I think roughly and maybe a year ago when we started really working with researchers and and some of these researchers are really, I'll consider some of them really world-class researchers. So we're good friends with a bunch of them from DeepMind, but also institutions like UC Berkeley, Stanford, and all that. And we started to realize that actually, basically, these researchers are very bottlenecked by data. They're also very bottlenecked by compute, and especially the academia in those that researchers in academia, obviously not in DeepMind. But also, like I mentioned earlier, they don't actually have the physical fleet of robot to test, to evaluate the models. Actually, one of the team that we work pretty closely with, they're one of the top like self-driving research team in Korea, and they told me that before meeting us, the last time they actually tested their models in the real world was 2 years ago. So I asked them what did they do the last 2 years. Everything was done in simulation. And so when we met them, we're like a bit of a godsend to them because we gave them data and then we gave them, more importantly, real robots to test in the real world. And they realized that they were very surprised on both ends of the spectrum. They were very surprised that, in some cases that models were really good, in some cases like really, really very bad, like, versus a human. So, and then as we talked to them a bit more, we realized, actually, they also wanted to do, let's say, other robotic tasks, right? So we actually started dabbling with, we started having robotic arms, they call it robotic manipulation, right? So we have a couple of research, collaboration going on with a couple of universities now on those. And so it just appears that, hey, there's a bigger thing to build here, even though we started off with cyber robot. And also because of this, kind of increasing interest in cross-embodiment research, we realized, we should just use crypto incentives to do all of them at once so that we have multiple shots on goal. And if we can really do that, then maybe the ambition should be a lot bigger. It should be not just gathering a data set. It should be literally solve embodied AI, meaning the final output should be a series of foundational robotics model that can work across all kind of robotic embodiment. So not just to gather data sets, although a bunch of our hopefully subnets will do that, right, to collect data sets, but there should also be a bunch of subnets that actually actively train up AI models, right? So, and actually there's a particular collaboration we did with the folks on DeepMind. So last year we organized this competition called Earth Rover Challenge with them, and it's basically AI versus human gamer competition, right? So on the human gamer side, we actually partnered with YGG, so we have a bunch of human gamers that basically are really good in the game. They're at the top of the leaderboard for the human leaderboard, and then we have a bunch of AI labs, from UT Austin and Singapore national universities and whatnot. So they basically try to play this game. TLD out there, basically the AI absolutely suck, right? But yeah, so humans are way better, at least for now. But what I realized from that competition, right, is in fact we're actually, there's a paper that's going to be dropped. We're co-authors along with the DeepMind guys and also all these researchers from these labs about the learnings from that competition. But what I realized, right, in that contest, that competition, you have researchers, and we started giving these researchers the data set that we started collecting on the cyber robot. But then they started turning around and say, hey, it's great you give us so much data, but we've never dealt with this level of data before, so and we don't have to compute. So what I ended up having to do is I started asking around in the crypto world, and thankfully, actually, I shout out to the guys from IONET and Exabeats. So actually, both of them gave us basically one box of H100. Like one box of H100 is 8 H100, so non-trivial compute, certainly in the academia world. And it turns out, actually, with the amount of data that we gave these researchers, with one box of H100, it would still take them at least 7 to 8 days to do one training run. So I just want to put some context about the size of data we're already talking about in the compute, right? And so anyway, the competition, I realized, okay, we have researchers, we have data, and then we have compute. How do we, but that the final outcome of the competition is a bunch of, AI models, right? So if we were to just treat it as another subnet, right, use again crypto incentives so that, the IONets of the world won't just give us one box and instead give us data center worth, right? And then we use the DeepIn thing to collect another huge amount of data in another subnet, let's say. But this particular subnet just focus on building AI models. And so we started to think, okay, actually we already have two subnets in a way. that's building. And so the goal, I think I incredibly, lucky to bump into Jonathan Victor. He's the ex. I think he came onto the pod before, right? Probably. Ex ecosystem lead at Filecoin, and then eventually I got to meet Juan Bennett, the creator of IPFS and founder of Protocol Labs. And so we just started jamming really seriously. I told them about the general idea of BitRobot, and so in about 1-2 weeks time, we'll basically drop the white paper, which is co-authored by the three of us. That talk a lot about the tokenomics and the concepts that we have in mind. So super excited to do that with them.
That's awesome. I have one question, Michael. Is BitRobot, is the name inspired by Bitcoin, by BitTensor, or some other bit?
Mm-hmm. Yeah, very much so. Yeah, and also I actually shout out to Sammy and Seth Bloomberg. Yeah, so I have multiple chats with them. I mean, history is like path dependent, right? And I think makers we all just built on the shoulders of previous giants. And honestly, if you present me something like a BitRobot, like the concept BitRobot, a year ago I would say that this will never work because at least before a year ago I didn't know there's something like BitTensor. I have yet to see a crypto network that actually really do a network of subnets well. And it's just not 2 or 3, but many subnets. But because we're on a timeline that DeepIn exists, right? Helium exists, and all the other DeepIn projects, and also BitTensor exists. I think is therefore natural that something like BitRobot should exist, and so it's absolutely paying homage to BitTensor.
Awesome. Yeah, I think last question from me, Michael, is I saw one that you guys launched, kind of like a sister meme coin, and it's tied to an AI agent that is driving around the world in a robot. So I think one, that's fascinating, but two, you also had some really interesting thoughts around launching a sister meme coin pre-TGE to build community, gather feedback in real time without, having to have your actual token out there and be very serious about everything you're doing. So maybe talk a bit about both of those points, because I thought it was a pretty interesting strategy.
Yeah, it's strange for me to say all this because I'm not a degen, definitely, but and I would say even 3 years ago when we first started this project, I was a complete anti. Like I thought all crypto are scam until I discovered Helium.
Nice, same.
So big shout out to Helium. Yeah, but I would say maybe in the last year or so, I started to come around this concept of meme coin. Of course, like meme coin, like this last week, it really, it's taking a real hit but anyway, I've come around the view that maybe meme coin is just a financial manifestation of a cult or a community basically. And it strikes me that, regardless of what kind of project you are, you could be a very, very serious DPM project, but ultimately you're trying to form a cult of some kind, a community of some kind. And meme coin could just be a very, very quick way to gather that, I guess. So I started to think that maybe, for very, very serious project, which is most DPM projects in crypto, should consider look into the other extreme of crypto, which is all the degens, right? But and if done well, but I do think that, I don't know. I mean, honestly, I'm just experimenting on the fly, so I don't know how well this will really turn out. Because what you absolutely don't want to do is to dilute, the seriousness and really the absolute amount of capital formation that you need right on the deep inside. And certainly for us, the North Star is definitely BitRobot. So SAM is like a silly experiment, if you will, right? But I think the silly experiment can actually drive a lot of attention, build the community. I would say ever since we do the SAM, a lot more people have found out about us. So already I see some benefit to that. Actually we have some pretty big announcement coming soon around SAM. But the whole idea is like I said, use a system meme coin, drive attention very quickly, and then hopefully using this community to do things that's ultimately beneficial to the North Star, right, which is BitRobot. Another thing I want to just add on that point is, I think that robotics, I mentioned earlier, it's going to take some time for a lot of these robots to be truly, at the human performance level. For most tasks, I think it's at least 5 to 10 years away. Especially humanoid, I think to be really generalizable humanoid, to replace a human, I think is, in my view, at least 10 years away. So if that's the case, then, what are robots today good for? I think they are great for entertainment value. So it is our very, thesis very, very early on, right? So the reason why we have robotic gaming is the same kind of reason as well. These things are fun to play with already. You can put a gaming lens to it. And so when a robot fails, it's not the end of the world. You're not trying to deliver a burrito. It's just it's to be expected because you just failed in a gaming mission. Completely fine. So that, and of course, like, lends quite nicely to a meme coin. It's frivolous. There's no pretense or utility. It's just all fun. Yeah,
100%. Well, great idea, and I think it always makes sense to kind of innovate and tap into the degen side of crypto. I mean, that's part of the speculative nature of the industry that we're all building in. So with that, Michael, it was great to have you on. Where can we point our listeners to find out more about you and Frotobots, the BitRobot network? Or if you have any kind of call to action in terms of buy some hardware, join the community, where would you point our audience to?
So the best way is to follow us on Twitter, Frodobots, and then we have a new handle for BitRobot Network. So follow us there. I'm MICOOLCHO, Michael Cho on Twitter. And then from there, you guys will be able to find all the other like relevant links. We have a pretty active Discord community, although mostly Web2 gamers actually.
Nice.
Although these days maybe more crypto guys are showing up. Also some researchers hang out on our Discord. I mean, we are starting to sell the robots, like I say, $150. So we don't have the tokens yet, obviously, but it's already something that you can play, like a Mario Kart in real life. So in fact, I would say quite a lot of the people that buy our bots right now do not know that this is a crypto thing. This is like an RC car, basically.
100%.
So, yeah.
Sweet. Well, thank you so much for coming on and telling us about what you're building.
Thanks, Michael.
Right. Thanks for having me. All right. Thanks, Connor.